So today we're going to look at the first half of lesson 13.3, which is basically the difference between radians and degrees, angles in standard form, and converting degrees to radians and radians to degrees. So let's start off with angles in standard form. So it's hard to tell here, but this is your initial side, and so I'm going to highlight that in green. So it's assumed that an angle in the coordinate grid, and remember we're going to go from 0 to 90 to 180 to 270 and back to 360. So this is starting on what's called the unit circle, but if I took an angle that starts here at 0 degrees and open it up counterclockwise, it would go in an exact circle, assuming that the length of this arrow remained the same, which would then be the radius of that circle. So an angle on the coordinate plane is in standard form when the vertex is on the origin. So here's the vertex of that angle, and the angle goes from here to here. And one ray lies on the positive x-axis. So this is your initial side. So the ray on the x-axis is called the initial side. The other ray, this ray right here, remember ray it starts with an endpoint and goes in one direction infinitely, so that's why these are called rays. Two rays make up an angle. So this other ray here, and I'm going to highlight that in red, is called the terminal side, which makes sense because that's where the angle stops. And then, as I said earlier, our counterclockwise rotation, typically we're going to go counterclockwise. And so from here we go against the clock. So to the left is typically how we find our angles, but you can go clockwise. If you go counterclockwise against the clock, your rotations will result in positive angle measurements. Whereas if you start here and go clockwise, which is to the right, that moves you in a negative direction. And then one full revolution, as I mentioned, all the way around the circle is 360 degrees. All right, so we are going to draw angles in standard position, and the first thing you need to have memorized, learned, however you want to phrase it, is that at 3 o'clock, which is right here is 0 degrees. And then we're going to move counterclockwise, and as we reach the top of the y-axis, that is 90 degrees because that's a quarter of the way around the circle. And then from here to here is 180 degrees because that's halfway around the circle. And then if I go from here all the way to here, that is 270 degrees, and that is 3/4 of the way around the circle. And then finally, if I travel all the way around the circle back up here to standard position, where we have 0 is also where we have 360 degrees. Okay, so if I want an angle measure that's 75 degrees, I know that it's somewhere between 0 and 90, and halfway in between, which would be about here, is 45. So you want to try to be as somewhat accurate as possible. So I am going to draw, here's my initial side, and then my terminal side, I'm going to draw, I don't know, like right about here. And then from here to here is my angle. That's a terrible arrow, but you get the idea, and that's 75 degrees. All right, so if we want to go negative, I'm going to make this bigger, easier for me to draw. So if you want to go a negative 160 degrees, we still start here at 0 degrees, but we're going to go clockwise. So from here to here is negative 90 degrees, and then from here to here is negative 180. So I'm going to stop there because we want negative 160. So negative 160, if I added halfway, which would be 45 degrees. So if I add 45 degrees to 90, that's what, 135 degrees. So we have to still go further to get up to 160. So I'm going to put my terminal side here. So my initial side will be here. And my terminal side, that's about right, is there. So then my angle goes in this direction. You do need to draw this arrow. You need to draw this arrow here because I don't know whether you're talking about this angle or this angle when you draw your angles. So make sure that you do have that drawn. And then I'm going to label this as negative 160 degrees. All right, so then 430 degrees is actually more than a full revolution, and so sometimes you can have that too. You can go an infinite number of times around the axis. So this is 0 degrees, and we're going to go in a positive direction, which means counterclockwise. So then we're up here at the north axis, 90 degrees. The west axis, 180 degrees. The south axis, 270 degrees. That's a 7. And then we're up here to 360 degrees. So if I want to go to 430, I'm going to go off here to the side. Let's do 430. And I'm going to subtract 360 to see how much further I have to go. So I need 70 more degrees. So remember, halfway is 45, so 70 would be back around here again. So here's my initial side. My angle's going to end up here. Whoops, that was a little not very straight. There we go. That's good enough for government work. So when you draw your angle arc, if you will, you have to go start here. You have to go all the way around one full revolution, so it kind of looks like a snail, and keep going until you hit that terminal side, and then you can put your arrow on there. And so then that represents 430 degrees. Okay, so there's those. Then let's talk about a radian. I'll make this a little smaller. There. So you haven't heard this term, well, you've heard me talk about radians before because we had to make sure that our calculator was in degrees and not radians for the last 2 lessons. So a radian is a unit of angle measure based on an arc length. So remember, arc length is like from here to here is the arc length, and it's how much of the circumference the circle is. So the length of that circle is the circumference, and arc length is how much that is. 1 radian is defined as the measure of, and we're going to take out this A. So 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So this angle right here, from here to here, an angle can be measured in either degrees or radians. So 1 radian is going to be equivalent to this arc measure, and it says that it's based upon, it's defined as the measure of the angle formed when the radius is equivalent, so we might want to highlight that here, so that's equivalent to the length of the intercepted arc. All right, so when the radius, so radian is when the radius is equivalent to the length of the intercepted arc. So here's the radius, the length of the radius, or here. And so I'm going to mark that with a tick mark. And then that length should be exactly equal to that arc length. So when this radius and that arc length equal, that means it's 1 radian. So that degree, 1 radian. So 360 degrees all the way around the circle is 2 pi r, because the circumference of a circle is 2 pi r. So we're going to say 2 pi because we assume that our radius is 1 unit of measure. We're trying to get you into what's called the unit circle, and so in the unit circle we always shrink the radius down to 1 unit of measure. So it's not going to be 2.6 or anything like that, it's 1 unit of measure. So that's why our r is 1, so we end up with 2 times 1 times pi, which gives us 2 pi. So then half of 360 is 180, so half of 2 pi would be pi. So one of the ways that we can label, and I'm going to put in here the x and y axes. Whoops, hang on. Let me move this over a smidge. I'm going to put in the x and y axes. Whoops, I missed it. Missed it by that much. And again. There, that's better. Okay, so if we were going to label these axes with radians like we did with degrees, we would have 0 radians here, and then halfway around would be pi radians, halfway around the circle. So then half the distance between 0 and pi would be right here. So we're going to label this as pi over 2. Pi over 2 is exactly equal to 90 degrees. Pi is equal to 180. And if we add another 90, remember that's 270. So if I add another half to this, 1.5 is the same as 3 pi over 2. And then I go all the way around, remember all the way around 360 degrees, we get 2 pi. So on our initial side here, which is where 0 is, we always have 2 angle measures, or in this case, 2 radian measures. So we go 0, half of a pi, a full pi, 1.5 pies, 2 pies. All right, then you're going to have to convert degrees to radians and radians to degrees. So our conversion is that pi radians is exactly equal to 180, because remember here, this is 0, this is 90, this is 180 degrees. So pi is exactly equal to 180 degrees. So we use that conversion. It's just like saying 1 foot is equal to 12 inches. So we're going to use 1 pi radian is going to be exactly equal to 180 degrees. So whatever your degrees are, it could be 147 degree angle. You're going to take 147 degrees and multiply it by pi over 180, because your degrees will cancel, because this right here is degrees, and you'll be left with radians in the numerator. Same thing with radians, only we flip our conversion factor. If I'm going to get rid of radians, I'm going to put pi on the bottom, because radians is in terms of pi. So your radian measure would be like, I don't know, 4 pi over 3. So you would multiply 4 pi over 3, because radians tends to be, not always, but radians tends to have pi in its value. And so we want to put our pi in our conversion in the denominator so it will cross cancel. All right, so let's put this into practice. So let's work on degrees to radians. All right, so if I take 130 degrees, I'm going to multiply this by pi over 180, that's an 80 degrees. And the reason I did that was because this is over 1, right? And so my degrees are going to cancel, and I'll be left with something in terms of pi. And that means that we took it from radians, or from degrees, and converted it to radians. So these degrees are going to cancel out. In addition, 1 0 on the end of every number will cancel out, right? And then 3 goes into 3 once, and 3 goes into 18 6 times. So all that we have left if we multiply straight across, is 1 times pi, which is pi, divided by 1 times 6, which is 6. Now, the other way that you could have chosen to do this, and this is your choice, we could have taken the 30 degrees over 1 and multiplied it by the pi over 180 degrees. And if I don't worry about cross reducing and I just multiply straight across like you do with normal multiplication with fractions, 30 times pi, and of course we're still going to assume, because the purpose of this is that our degrees do indeed cancel out. So 30 times pi is 30 pi over 1 times 180 is 180. So you will have your calculators available to you. So if you want to put into your calculator 30 divided by 180, ignore the pi for right now, you'll get a decimal. And then remember, if you hit math enter enter on your TI, it will reduce it to 1/6, which is what we had here. You just can't forget to put pi back into your answer. So you would end up with 1/6 in the calculator, which means it's pi over 6. Both of these giving you the same answer. So I don't care which way you do it, you make a choice. All right, so then I want you to try 5 and 6 on your own. It doesn't matter that this one is negative. You still multiply both of these by pi over 180 because you want the degrees to be diagonal to each other. That's how you remember whether it's pi over 180 or 180 over pi. If I start with degrees, I want to get rid of degrees, so I'm going to put degrees diagonal to what I have here, so that tells me pi has to go up top. So pause the video, do 5 and 6, and then check. Okay, so for 150 degrees, you should have multiplied by pi over 180 degrees, and then that reduces to, remember that's over 1, so that gives you 150 pi, the degrees canceled, over 180. And if you reduce it or put it into your calculator and hit math enter enter, remember you don't put the pi part in the calculator, just 150 divided by 180, and then math enter enter, you will get 5 pi, because you got to put pi back in the numerator, 5 pi over 6, and technically its unit of measure is rad, which means radians. All right, and then for 6, we're going to put negative 220 over 1 and multiply it again by pi over 180 degrees. So our degrees are going to cancel, right? So the degrees go away. And if you multiplied straight across, you would have negative 200, oopsies, negative 220 pi, all divided by 180. And then you're going to take negative 220 divided by 180, ignore the pi for right now, and hit math enter enter. And that will reduce to negative 11, and then you have to put the pi back in the numerator, divided by 9. And that is radians. We abbreviate radians by rad. Okay, so the last thing we're going to do today is convert radians to degrees. And I know that this is in radians because it has pi in the numerator. So if I want to get rid of pi and get to degrees, I know that I'm going to multiply this with pi diagonal to the pi I'm trying to get rid of. So if pi is in the denominator, 180 degrees goes in the numerator. So again, our pi's are going to cancel. That was the whole point of doing this. And then you could either cross reduce, 3 goes into 180 60 times, and then multiply it by the 4, or you can just take the 4 and multiply it to the 180. So we get 720 degrees over 3, and then 720 divided by 3 is 240 degrees. Remember, our degrees did not cancel out, and that is our unit of measure. Okay, so you try this for 8 and 9. Pause the video, multiply by 180 degrees over pi, and then let's check your math. All right, so you should have multiplied this by 180 degrees over pi. Your pi's are going to cancel. And you have a negative 900 degrees divided by 36. And negative 900 divided by 36 is negative 25 degrees. And our last problem, number 9, you should have multiplied by 180 degrees divided by pi. Your pi's cancel, and you have and that's in degrees over 4. And then 1260 divided by 4 is 315 degrees. And that's it. So long as you can draw an angle in standard form, which is all the way up here. So that's one skill that you need to have down today. So drawing that angle in standard form, also knowing that you start at 0 and go to 360, and that gives you a positive angle, or going backwards, 0, right, to negative 360 will give you negative values. Also that you can go more than one revolution around, right, and it kind of looks like a snail. And then I want you to definitely know that 1 radian occurs when the radius is exactly equal to the arc measure, and that 360 degrees is exactly equal to 2 pi, and let's add on to here that this would be 2 pi radians, that's rad, and then 180 is exactly equal to 1 pi rad. And then knowing that you multiply degrees by pi over 180 to convert to radians. And finally, that you know to multiply by 180 degrees over pi to convert radians into degrees. All right, try your homework and let me know if you have any questions.